All right, guys, so we've learned about different types of data. So now we're going to learn about how we can display that data. Alrighty, so one way we can show things is using a dot frequency graph. So for example, this is saying it's very useful when it's discrete variables. So for example, we've got frequency here up to 5 and class size, so number of pupils. So that means there's two classes that have 25 people in the class. There is three classes that have 20 people in the class. There's one class that has 15 people, etc. All right, so it's very useful with discrete variables, so whole number answers. All right, and then we've got histograms. So if we had the continuous variable, so this is very useful for continuous data. So if we were looking at the data from length of a newborn baby, suppose that they calculated the length of 50 babies, recorded to the nearest centimeter, then they got this data here. So we've got length, centimeter, and how many times that occurred. So we've got one baby that had 47, was 47 centimeters long to the nearest centimeter, et cetera, et cetera. Our most common was 14 babies were measured to round to 51 centimeters. All right, so the useful thing about so histograms, it could that data could have been represented as a dot plot, dot frequency diagram, but it doesn't really show the data very well because we can't see. So there's two babies that were recorded at 54 centimeters, but that could have been anywhere between 53.5 and 54.5. The dot frequency plot isn't showing that. This is where histograms come in useful. So histograms do not have gaps between the columns because each class begins exactly where the previous one left off, except occasionally there would be a gap if the frequency of the number, potentially anywhere along the line, is 0. That's the only time you'd see a gap. All right, so for example, now looking at our the two babies that were recorded at 54 centimeters, it's saying that there's two babies from 53.5 centimeters to 54.5 centimeters. All right, because remembering that we rounded to the nearest centimeter. Histograms, the vertical axis is always frequency, all right, and the horizontal axis is the range of values. All right, so for this, it's length in centimeters. All right, so continuing with that, sometimes the frequency in each group can be shown as a fraction of the whole. So this is that same data again about the babies, which is called relative frequency. So for example, we had one baby recorded 47 centimeters long, which out of all the babies recorded, so you'd have to add all that up, the relative frequency would be 0.02. Or it could be represented as a percentage of the whole, so 2% of the babies were recorded at 47 centimeters. All right, histograms can also be used to show frequency polygon, which is formed. So this one on the left. Where'd my mouse go? There it is. All right, so this one on the left. So this is showing relative frequency. So we've taken all these relative frequency values and our lengths and plotted them that way, and then our percentage frequency. And so a frequency polygon is formed by connecting the middle of each bar to the next bar. So we've got middle of the bar to the next one, to the next one, to the next one. All right. It makes a shape which can help make the continuity or the changes more evident. All right. So also discrete data, we wouldn't necessarily expect it to be used with histograms because of the gaps that are between the discrete data, but they can still be quite convenient. So we would need to choose our class boundaries, that's our horizontal axis, to be midway between the possible discrete values. So for example, if this is our data, we would need to make sure that, so our options between 1 and 2, so we need to pick halfway between there. So the 2 parts frequency that was recorded for number 2 would need to go from halfway between 1 to halfway between 2 and 3, just like it is here. And here's an example of that gap occurring in a histogram because the frequency is 0. It's also very useful for grouping data, discrete data. So for example, if you looked at this data, which represents 25 scores, no scores are repeated. So if we were to display the scores as a frequency table or as a dot frequency graph, we have 25 scores shown, each with a frequency of 1, which wouldn't be very useful or tell us anything. So in this case, the data may be better presented grouped using intervals. So for example, we could have 1 to 5, then 6 to 10, 11 to 15, so they'd be in groups of 5. And we could display the data this way. The grouping then becomes what's shown in the table below, and some information is lost because the 25 scores themselves are no longer given, but the grouping makes a distribution more evident, whereas with 25 individual scores, there wasn't any obvious patterns. But now we can see that there's not a lot on the ends between 1 and 10 or 41 and 50, and a majority of the scores are lying around the middle, which is 21 to 25. So even though we're not seeing the exact scores in between them, we can see the general patterns. And then this data, this group data, could then be displayed as a histogram. All right, so what's the difference really between a histogram and a bar chart? You guys have been using bar charts for a long time. So they do both show the frequency of something occurring. However, a histogram shows a normal number line on the horizontal axis, whereas the bar chart shows categories on a horizontal axis. The bars in a histogram cannot be moved around, whereas you could change the order of the bars in a bar chart. For example, if you wanted to change your categories around to make the bars go in decreasing order or increasing order, or to show something specific. The beginning of one category in a histogram takes over immediately at the end of the previous category, so there's no gaps there, whereas a bar chart does have gaps between. Alrighty, all done.